Hello guys. Welcome back. Thanks for showing interest in the video tutorials on www.logicvoltage.com. This is the third tutorial on the video tutorial series on interfacing LCD with STM32F4Discovery board. In this series we are learning how we can interface a LCD and display on it using STM32F4Discovery board. You can check out the website www.logicvoltage.com. In the website, there are many other STM32F4Discovery video tutorials. You can watch them and learn. You can even check out the video store at the website. It has some good tutorial series there with very less price. Lot of peoples are buying it. You can also buy them and learn some very awesome things about embedded programming. You can even get in touch with us also. Just go to Contact Us page and fill up the form, and we will reply. You can even check out the forum also. For any tutorial related query or any technical questions, just create a new topic in an appropriate forum and write your questions and doubts. And we will reply you there so that other people can also see the comments and what discussion is going on. Thanks. Okay, so till now we have built the circuit. And then we have already created a new project, and started writing the program. In the last tutorial, we have written this function, LCD_pins configuration. In this function, we have configured and initialized all the discovery board pins in alternate function mode for Fsmc. So now in this tutorial we will understand how we are trying to achieve all this. What exactly we will do to display something on LCD. In this tutorial, we will not do any program writing. Basically this whole tutorial is for understanding the key concepts of displaying on LCD. Okay, so now I will show you how the overall process works. Let's say we have discovery board and the LCD module here. And you already know that we will be using the Fsmc peripheral for displaying on LCD, and we have already configured and initialized the Fsmc pins. So let's say this is the Fsmc peripheral which is present in the discovery board. Now in the LCD module, we have a part that actually takes care of displaying on the screen. Let's call this part LCD display. Okay, so now next thing is, we have many registers in the LCD. These LCD registers are actually in a RAM memory where all the processing happens. And each register has a unique address. For example, you can see that we have 00, then 01, then 02, then 03, then 04 and so on. And each address has a specific purpose. That means whatever the data written on any register, the LCD display part will act accordingly as per the data. For example, some register is used for configuring different color options. Some register is used for configuring different power options. Some registers are used for configuring how to display, like in landscape mode or in vertical mode. So similarly we have many registers like this for specific purpose. So what actually we have to do is, write data on some specific registers, and then LCD will start displaying on the screen according to the data that we have written. So now you understood how LCD is working behind the scenes. Now next question is how we will write some data on some specific address of the LCD. For this we will use the Fsmc peripheral of the microcontroller present on the discovery board. and we will configure and initialize the Fsmc in such a way that Fsmc will write our data on a given register address on the LCD. Now next question is, how actually this happens? I mean how we will tell Fsmc to write data, and how we will tell on which register the data has to be written. For this we will use two memory locations on our discovery board. Now you can see in the screen that I have shown two memory addresses here. One is 60 million, and the second one is 60,020,000. Now these two address locations are actually in the microcontroller's internal memory. Now why I picked these two addresses and not any other, that I will tell you later. Now these are the steps of this whole process. So let's go with the steps one by one. Please pay special attention to these steps because, if you don't understand the steps here, then you might not understand the later part. So the first thing that will happen is, we will write the LCD's register address at this location. With this line what I mean is, let's say we want to write 9F5D on register 01 of the LCD. So at the 60 million memory location of the microcontroller, we will write the register address which is 01. The next step is, we will write the data to be written at the LCD's register. With this line what I mean is, we will write the data that we want to write on the register whose address we have given above. So if we want to write 9F5D on register 01 of the LCD, then at the 60,020,000 location of the microcontroller, we will write the data which is 9F5D. So basically we are first writing the register address at the first memory location, and then we are writing the data on the second memory location. Then the third step which is, Fsmc will automatically write the above data at that particular register. What this means is, Fsmc will automatically write the data that we have given on the second step, to the register whose address we have given on the first step. Fsmc will automatically do that. We don't have to do anything. We have just connected all the wires from the Fsmc pins from the microcontroller to LCD pins. And rest Fsmc will take care. Then the fourth step is, LCD display will automatically act on its registered data accordingly. What this means is, LCD will automatically start taking action on the data that Fsmc has written on the LCD's register. Hence as per the data and register we will provide, the LCD will start displaying on the screen. Now next thing that will come in your mind is, which register we have to write and what to write. That is where datasheets come in handy. We have to look into the LCD display driver datasheet, and find out how many registers we have in the LCD, which register has what purpose. And on the basis of that we will decide. Now one more question that may come in your mind is, how actually Fsmc is writing on the LCD register? Well, the main purpose of Fsmc peripheral is to write on external memories. And it's not like that Fsmc will automatically does everything. We first have to configure and initialize the Fsmc peripheral and then Fsmc will act accordingly. But yes, with Fsmc, our most of the work will happen automatically. And to find out how exactly Fsmc is writing data to LCD memory, for this we can look into the Fsmc section on the microcontroller's reference manual. There all is documented and you can read it from there easily. We will not cover all details about the Fsmc peripheral in this tutorial series as it is a big topic, and has much more things to learn. But yes, whatever needed for displaying on LCD, we will learn and understand only those sections of Fsmc. Now the last thing that I haven't told you yet is that, why I have chosen these two address locations in the discovery board and not any other. We will now look into that. But before that, I hope you understand all these steps. If you still feel not comfortable, then again watch this part of video, or you may find more difficult to understand the later part of the tutorials. Okay, so here I have opened the reference manual of the STM32F4Discovery microcontroller. Here let's go to the Fsmc section. Let's go to page number 1523. Okay, so now here the Fsmc peripheral is documented. Now next thing is, why we have came to this. It's because, I still haven't told you why I have picked those two address locations from the internal memory of the microcontroller and not anything else. So let's scroll down few pages. Okay, so here you can see a diagram of Fsmc memory banks. Basically the Fsmc supports these types of memory: NOR, PSRAM, NAND, and PC card. So we can use Fsmc for writing any of these types of external memory. Now for writing on LCD, we have to use the first one, that is NOR, PSRAM. And basically it will be SRAM. SRAM is not shown here specifically, but it is also part of this memory type. We are using this memory type because, in LCD, we have this type of memory. Now next thing you can see here written, Bank 1, Bank 2, Bank 3 and Bank 4. So basically, from the Fsmc point of view, the external memory is divided into 4 fixed-size banks of 256 megabytes each. And we have to use only that bank whose corresponding memory type we want to write data. That means, as I said, that we have to use the first memory type, that is NOR, PSRAM. And its corresponding bank is Bank 1. Hence we have to use Bank 1 for writing any data on LCD. Now next question that will come in your mind is, what is meant by using Bank 1? How actually we will use the Bank 1? Well, what this means is, we will write all our data in Bank 1, and Fsmc will automatically write that data from Bank 1 to external memory, which in our case is the LCD. Now if you can see here that it is written as, Bank 1 starts from address 60,000,026FFFFFF. What this means is, these are the internal memory locations on the microcontroller. And between these two addresses, whatever data we write, all that comes in Bank 1. So between these two address locations we will write the LCD's register address, and the data that we want to write on that register. And if we now go back and check that earlier diagram that I have shown, here the first memory address that is written is 60 million. And this address is matching with the start address of the Bank 1. So you can see how we have decided this address. Now next thing is, how we have decided the second address. So basically whatever we have to write to the LCD, we will write in this Bank 1. But how Fsmc will decide if the data we have written in the Bank 1 is the register address and not the actual data? How it will differentiate between the two? So for this, it has divided the Bank 1 in parts. Okay, so you can see here a chart on the screen. Here two columns are there. First one is address, and second one is data type. In the address column, we have written location of the memory address within bank 1. And in the corresponding data type column, you can see that which type of data we have to write. So here you can see why I have initially chosen 60 million for LCD's register address and 60,020,000 for data to be written. Because the bank 1 is itself divided into these parts. Now one thing to note here is that I can choose any combination of these pairs. That means I can either choose the first and second row, or third and fourth row, or fifth and sixth row, or seventh and eighth row. So we can use any pair for writing on the LCD's register. So here we will choose the first and second row for writing on LCD's register. Okay, I hope now you are clear on why I have chosen these two memory locations on our earlier diagram and not just any memory location. Because we have to use the Fsmc bank 1. Now next thing to understand is how we will write on the LCD. How LCD will actually display the characters. Well, to understand this, we first need to understand the LCD itself. Okay, so let's understand how we will display on LCD. Now before going forward, the first thing to understand here is, we will display only characters on the LCD. As I already shown you in the first tutorial of this series, that we will finally print some characters on the LCD. So whatever we will learn here will only for displaying some characters. Now why I am saying this, that's because we can actually display anything on the LCD, from characters to images and videos etc. But displaying images and videos needs a bit more learning. Hence in this video series, we will mainly focus on displaying characters. Okay, let's understand the whole process. Let's say we have LCD here. Okay, now in this LCD, we have many pixels. We have total 240 pixels in vertical, and 320 pixels in horizontal. Now these pixels are the actual points on which we have to program. We have complete control over these pixels. We can make any pixel of any color. So if we make a group of pixels of a particular color and make the remaining pixels in another color, then we can display something. For example, let's say we make the third row of pixels in black color, and then make the remaining pixels in white color. So when we will see the screen, then we will see a horizontal line. Hence in this similar way we can actually display any characters by setting the color of the pixels. Okay, so now our main focus is on displaying characters. For this we will assume something. Okay, so now you can see a group of pixels. We have taken a block of pixels, out of many pixels in the LCD screen. Actually we have taken 16 by 8 group of pixels. So basically what we will do here is, we will divide the whole screen in these 16 by 8 block of pixels. And we will use this block to display one character. That means a single block of pixels like this will display only one character. And it can be any character. Now to display next character, we will take the next block of pixels like this and display the next character. Now you may be wondering why we are doing this? And why only this group of pixels? And why not a bigger group, or a smaller group of pixels? Well, we can take a bigger or a smaller group of pixels also. Actually it's up to you. It's decided based on the size of the characters you want to display. If you want to display large size characters, then you can choose bigger block of pixels. But in this tutorial we have taken this size only, as this looks comfortable to us for displaying. Now next thing is how actually we will print a character in this block of pixels. For this, we will create a font file. We will actually create a separate file called font file. And in that font file we will actually save font data for each ASCII character. And we can print those characters whose ASCII data is saved in the font file. Let me show you with an example. Let's say we want to print an alphabet. So for that we will create a font data for a character in the font file. As you can see in the screen that we have shown the font data for a character. Here you can see, we have a complete row of total 16 hexadecimal numbers. This complete row is actually the font data for the A character. Now these 16 hexadecimal numbers are actually make the A character to display on the LCD screen. Now you may be wondering how these 16 hexadecimal numbers can lead to a character? And why 16 numbers only? It's this fixed? To answer that question, let me first show you the block of pixels also for displaying one single character. As we have decided that we will use 16 by 8 block of pixels to display one character. Now these 16 rows is actually corresponds to these 16 hexadecimal numbers in the font file. As we have 16 row in our block of pixels, that's why we have taken 16 hexadecimal numbers. Now next question is how actually they correspond to each other. How actually a character will be printed in this block of pixels. So let's understand this process. Okay, so now you can see that we have a list. In this list you can see that we have actually converted all the hexadecimal numbers from the font data of a character to 8-bit binary numbers. Now we have to put these binary numbers in this block of pixels. Here we have total 16 binary numbers and each binary number is 8-bit. Now if you closely look into these binary numbers, then you may realize that each bit is actually representing each pixel. Okay, let's assume that currently we have all pixels on this block is of white color. Okay, so now what we will do here is we will start putting each bit on each pixel one by one. Basically what I mean is, for a bit 0, we will make the pixel white color, as by default it is white so no problem. But when we get a bit 1, then we will make the corresponding pixel to black color. Let's see how this will work. Let's take the first binary number, which is all 0. Now all 0 means all pixels will be white color. Hence no change as by default it is white. Then take next number. Again all 0 hence all pixels white. Then take next number. Again all 0 hence all pixels white. Then take next number. Now in this case we have first 3 bits are 0, hence white color pixels. But the next 2 are bit 1. Hence we will make their corresponding pixels in black color. And then again the remaining 3 pixels of white color. Then take next number. Here you can see we have total 4, bit 1, and hence we will make their corresponding pixels in black color. Rest are white color. Then take next number. Again here you can see that we have made the pixels black color whose corresponding bit is 1. And in this same continue this till the end. Let's see that. Now you can see that we have displayed all the binary numbers one by one. And we have make all pixels black where binary bit is 1. Now if you see closely the block of pixels, then you can see that we have actually displayed the A character. If you are still not sure how, then look at this. I suppose now you get it. As I already told you that we are making all the pixels in black color, where binary bit is 1, and rest in white color. So when you will see this on the screen as a whole, then this will look like a character. Awesome, right? Hence in this similar way we can actually print any character on the LCD. Only thing is, we have to create the font data by ourselves for each character, and then we can print the character on LCD. Now one thing to note here is that, it's not the LCD that will do all this conversion process, from font data, to actually changing color of pixels. All this has to be done by us using our program. Only thing LCD will do is, display the pixel with the color that we provide. Rest all this conversion process has to be done by using the programming skills. Okay, so you can see that how easy to print a character on the LCD. Well, you might think this seems easy to understand, but it's not that easy when you will actually try to achieve this with programming logic. That's why I told you earlier that, this video series needs a bit of programming skills also. But don't worry, we will try to make you understand everything as easy as possible. And if you have done a bit of programming earlier, then you will understand here all the programming logics easily. Okay, I hope now you have understood how we will display characters in the LCD. Okay, so from next tutorial we will resume writing the program that we have stopped in the last tutorial. Okay, once again this is from www.logicvoltage.com, and thanks for watching. Bye.